Okay, question 20. The worksheet is forces on threaded ring. A small ring P of mass 0.03 kg is threaded on a rough vertical rod. Okay, so I'm going to draw the direction of weight. Weight is mass times 10. So it's going to be 0.3 newtons in the downward direction. It says it's a rough rod, so that means there's going to be friction on the rod somewhere, either upwards or downwards, depending on the direction of motion. A light inextensible string is attached to the ring and is pulled upwards at an angle of 50 degree. Okay, the tension is away from the mass, so it's in this direction. I'm resolving its component. This one is going to be the adjacent component, so it's going to be the cos component, 2.4 cos 25. And this one is going to be the opposite component, which is always the sine component. So upwards, it's going to be 2.5 sine 50. Okay. Next, there's going to be a normal contact force on the system. Since it's being pulled in this direction, the contact will be here and R is going to be perpendicular to the contact. So we have a normal contact force in this direction. The tension in this ring is 2.5 Newton. The ring is in limiting equilibrium. And on point of sliding up the rod. Okay. That means when it will move upwards, which means friction would be downwards. So I'm writing F for friction, and we know friction is equals to mu R. Okay. And we need to find the value of mu, which is the coefficient of friction. Okay, now let's equate the forces since the system is in equilibrium. Up forces, which is 2.4 sine 15, would be equals to the down forces. There are two down forces, 0.3 plus 2.5 cos, no, there's 0.3 and the friction, which is mu R, plus mu times R. Okay, now we need the value of R. So now we're going to equate the left forces, which is just R, is equals to the right forces, which is 2.5 cos 2.5. Okay, now I'm going to replace this R with the value 2.5 cos 15. Sorry, this was 15. Why did I write 2.5? And this is also 50. Okay, so value of mu is going to be 2.5 sine 15 minus 0.3 divided by 2.5 cos 15. And that comes out to be 0.144.